So from the midterm, we saw that the general solution of ut equals kuxx, the heat equation, with boundary conditions, homogeneous Dirichlet boundary conditions, we saw that the general solution looks like a summation of e to the minus k n pi over L quantity squared t sine n pi x over L for some choice of C. So to make the notation a little easier on the eyes, let's consider k equal to 1 and L equal to pi. And so this becomes a little simpler. The k drops out and the pi's and the l's cancel. So we have, see, k is gone, these guys are gone, bing, bang, bong. And we end up with, well, that looks sort of silly, n squared t sine nx. Okay, suppose we add the initial condition of f. Well, then evaluating this at time 0, we get that the exponential term drops out, and this has to look like just Cn sine nx. So we have to be able to solve this. And so then the question is, for what sorts of f's can you solve this? And Fourier's answer was, well, anything. And the rest of the mathematical community thought that he was a little haywire. But he turned out to be almost entirely correct. So we can actually find those coefficients Cn. And so here's the thing. So if we take this equation that we're gunning for here, so let me just take this guy, drop a copy of him right here, and I'm going to multiply both sides of this equation by sine mx, and then I'm going to integrate from 0 to pi on both sides. Then I'm going to just brashly interchange the integral and summation here with no regard for personal safety or well-being. And then let's see. Well, we can take the that Cn outside of the integral, so I might as well go ahead and do that. Okay, so we've got this. And then it turns out that this integral is going to be 1, sorry, not 1, is going to be pi over 2 whenever n is equal to m, so that we're looking at the integral of sine nx squared. And it's going to be 0 if n is not equal to m. And so because of this fact, in this summation here, the only thing that survives the sum is Cm. And so that tells us then that Cm is 2 over pi times the integral from 0 to pi fx sine mx dx. And so if we put that back into our formula, we have that fx can be written as the sum of, and so here's our CMs. Oops. And just to sort of tidy or simplify this expression a little bit, let's write this one as the summation of, and I'm going to use this symbol with the corner brackets here, angle brackets, to indicate the integral, the normalized integral with the pi over 2 out front. And maybe that's still not quite simple enough, so I might write this as the sum from 1 to infinity of f against Vn times Vn. And so here, Vn is my shorthand for sine nx. And this angle bracket symbol that I'm using, actually here, let me just do it for generic things u and v. So the definition for this is 2 over pi integral from 0 to pi ux vx dx. And so that's Fourier's method. And it seems to indicate that pretty much any f can be decomposed in terms of a sum of these sine nx terms where the coefficients are given by these integrals.